Welcome! In the next several levels, we will build a graphics editor with its own shape libraries and sets of commands. Through this process, you will be introduced to program design and in particular, how to design an application program interface, or API. In this video, we will look at a program design for our graphics editor. We will look at the specifics of the API in the next video. Let's review the drawing procedures we have used so far. We have learned how to draw shapes by creating X and Y arrays based on geometric parameters. We can also include several shapes in the same drawing by adding these arrays and separating each one using the keyword none as a line break. This creates one list containing all the shapes. We then declare parameters such as color and line width and plot the results. For simple, uniform drawings, a program design such as this works just fine. We only have a few objects, so we don't have much difficulty identifying them either individually or within the final list. The drawing is relatively easy to code. However, once our drawings become complex, this simple design starts to show its weaknesses. For one, it becomes difficult to tell one shape from another. Creating labels for each one will be helpful. Our simple design has other limitations. The line and fill characteristics are assigned at the end of the whole list, so all shapes are rendered in the same way. We would like the flexibility of assigning line and fill characteristics to individual shapes. How do we redesign our program? It helps to try out some ideas, then pick the best option before writing the code. Let's look at two alternatives. We could continue our simple data structure by creating a list for each operation. The array coordinates first, then labels to identify each shape, then line widths, and so forth. However, all the separate lists would be difficult to manage. Every time we edit a shape, we would have to work with several lists. A better way would be to create a list of parameters for each shape object. It is much easier to visualize and edit a shape's characteristics in one list. We are going for the second option. For now, we will limit ourselves to 6 parameters. Let's take a look at each one. The first 2 parameters are the familiar X and Y arrays needed to draw the shape. The third parameter, our label, is a text string. This object identifier helps the programmer and the program locate objects in the data structure. For example, in the drawing of an airplane, we may need to create labels such as nose, wing, or wheel. We will assign the color using a text string. For example, color equals orange. There are other ways to assign color, but for now, we will use strings and the named colors in the matplotlib library. As you can see, there are plenty of choices. Our next parameter, line width, is a float value. For example, line width equals 1.6. Float is shorthand for floating point real value or floating point decimal number. Finally, we can decide whether or not we want to fill the object with color. This is a yes or no decision, so we will use Boolean flags, fill equals true or fill equals false. Once we have created the lists for each object, we can append them to the master list for the drawing. Our drawing list is a list of lists. This design choice allows us to identify, customize, and edit each shape without impacting the others, add and remove shapes from the list, and add more parameters to our shape list if we so desire. Thinking ahead can save hundreds of hours of coding, debugging, and patching up poorly designed programs. Always keep in mind that we want a program that is easy to use, easy to maintain, dependable, and efficient. This is what we call smart design. In Part 2, we will discuss application programming interfaces in general and walk through the construction of our graphics editor API. I look forward to working with you in the next video.